Welcome back to my channel. Hope everyone is doing great in their life. Let's solve today's Leetcode problem. 2300 successful pairs of spells and portions. Okay, we have been given two arrays named spells and portions. Okay, and we have been also given an long variable success. Okay, we have to perform some action over here. For each spell we have to multiply with all the portions. Okay, for each spell we have to multiply with all the portions. That will give you the overall strength, okay, of that particular pair. If the strength of the particular pair, if it is greater than or equal to the success, that means this is a successful pair. Okay, and we have to basically calculate those number of successful pairs and then add it in our answer array. Okay, so for 5, if you multiply with all the elements, this is the corresponding array which will be formed. And if you see among all these pairs, these 4 elements are actually greater than or equal to success. As a result, there are 4 pairs which are successful. So we have just populated against 5, there were 4 pairs which were successful. Similarly, we have to perform it for 1 as well. If you multiply 1 with the entire array, you will get this particular response, and there are no such pairs. There is no pair which is actually greater than or equal to success. As a result, we have sent it as 0. For 3, once we multiply it, there were 3 pairs possible. Okay, so if you look at the constraints over here, n and m are actually 10 to the power of 5. Okay, brute force solution would be straight away replicate the process which they are explaining, and then form the answer array and return it back. Okay, that would take order of n square, which would actually fail for the given test cases, for the given constraints. Okay, so can we do anything better over here? Okay, so for a given spell we have to identify all the pairs. Okay, we have to identify what all portions we have to choose. Okay, so let me go back here. Okay, so I have taken the second example. So if 8 is for the given example, if 3 multiplied by 8, 5 and 8, we are getting 24, 15 and 24, right? So there are 2 pairs which is 24 and 24. Okay, if you closely look into this particular thing, so idea is to identify the first element which is actually satisfying this condition. Okay, first element whose pair is actually getting successful. If we can sort these portions, okay, if we can sort the portions, and for each spell if we are able to identify the first portion which is actually satisfying the condition, which is actually eligible for successful, then all the elements which are next to the particular pair will also satisfy. Okay, so if I have 8, 9, 20, okay, if 8 is successfully able to pair with 3, okay, if 8 is successfully able to pair with 3 spell, then obviously 9 will also be successfully able to pair and 20 will also be successfully able to pair it. Okay, so this is the main intuition over here. Identify the first element which is actually eligible for to be successful, and all the elements next to it will also be able to be successful. Okay, so how can we effectively identify the first element which is successful? Okay, which is potentially eligible for successful. If one approach would be using linear, you can linearly go through the entire portions array and identify it, which would actually take order of n time complexity. Since we have already sorted this, can we utilize this sorting behavior of the array? Okay, so whenever we array sorted, think of binary search. Okay, since all elements are sorted, can we use binary search in order to find the first element which is actually less than or which is actually satisfying the condition? Okay, so what we will do first, we'll calculate the mid. If mid is successful, that means all the elements to its left will also be successful. So our answer will potentially lie either on the mid or on the left part of the array. Okay, so I will basically string my space to mid. Okay, my left would be here and my mid would be here. Again I will repeat it, my process. Again I will calculate my mid. Is my mid potentially successful? Yes, it is successful. So again I will update my mid to this particular, update my right to mid, and I will check in the next subspace. Okay, now the mid would be 5. Is mid eligible to be successful? No, it's not, right? So I will move to my right space now. So my left and mid would be over here. Now I'm now I have to check whether my left is actually eligible for successful. So whenever I exceed, come out of my loop, again I have to one more time I have to check whether it is successful or not. Okay, so let me just jump back to the code and show you the both brute force approach as well as the optimal approach. So in the brute force approach, I will be just iterating through all the spells and all the portions, and I will have a counter called count, and I will just calculate the strength of the corresponding pair, and then if it is greater than or equal to success, I will simply increment the count and populate my answer. Okay, this is brute force, which will be order of n square. Okay, let's look at the optimal approach which I have mentioned. Okay, the first thing is we have to sort our array, sort the portions array. Okay, which would take order of m log n, where m is the size of the portion, and I have just instantiated the answer which is equal to which has a length equal to spells, and I will just iterate through each spell and get the first successful element, okay, in the portions. Okay, so I just defined a utility method called load bound, which will actually apply binary search on the portions and check and get the first element. Okay, if I am not able to find the first element which is actually successful, then I will basically return -1. Okay, so let's look at the lower bound function. Looking at our lower bound function, okay, where I have just instantiated my left and right. As long as my left is less than right, I will calculate my mid and check whether I am successfully able to find a portion or not. Okay, if my mid is a valid portion or not. If my mid is a valid portion, okay, then I will update my right pointer to the mid, and else I will update my left pointer to mid plus 1, and this loop will keep on run. And if once this criteria will break, then again I will check my left portion is actually valid or not. If it is a valid, then I will return left, or else I will return -1. Okay, so once you find the first successful portion, then all the elements which are actually greater than next to it will also be successful. So from that particular index all the way till the end would be successful. So I am just calculating the length. Okay, that would be my answer. If I am not able to find a successful element, then I would update it with 0. Okay, so if you just submit the solution, this will actually work. Okay, yeah, if you see, our solution beats 95% of the solution which were already submitted, and it's pretty efficient. And the overall time complexity for sorting, it would be m log n, and for each element we are actually applying this binary search algorithm. So it would be n times log m, whatever is the maximum, that would be the overall time complexity. Understood? Yeah, that's all about this problem. Do subscribe to my channel for more such coding videos. Thank you.